So we'd like to welcome Jonathan Giroir to the stage next.
Check, check, check. Good, we are good to go. Maybe we can get us some slides up. So, hello everyone. I wanted to talk a little bit about building applications using software development kits and open standards. So, I'm Jonathan Giroir. I work for TechSoft 3D. My background is computer science and software development. I've been working in this space for over 20 years, specifically in 3D and image processing. Now in 3D engineering with TechSoft 3D, we supply SDKs to over 600 different companies in the 3D engineering space in a number of different industries, including AEC, and we're going to be focusing on building applications, particularly in AEC. I come from our headquarters in Bend, Oregon, where it snowed last weekend, so coming to a heat wave is pretty intense, but it's really great to be here. So let's talk about building 3D software and the different components that you would expect and you would need to have there. And we're going to just give you a quick survey of all the different tools available in the market. So not just the cesium tiles and the Bentley iTwin tools, but then what else is out there. So there's really 4 components that would go into building a software application. Like let's say you wanted to kill Revit, what would you actually need to be able to do that? First and foremost is good data. You need good data to be able to bring it in. There's a ton of data out there, legacy data that you want to build on top of. And so having access to rich data and then being able to do intelligent things with that is going to be really important. Next is what do you do with that data? And many times we want to augment and change, alter, edit that. You need a math kernel of some sort, so you need some modeling tools as well. There's a whole suite of different SDKs that allow you to do that. Simulation is really important, being able to show what is your structure doing under stress, when it is exposed to heat or wind, and be able to model that. So simulation is important as well. We're not going to talk about that a ton today, but there are a lot of open and commercial SDKs available for that. And then of course graphics, and so what is out there when it comes to desktop and web graphics. So we're going to give you a quick overview of some of those things. We're going to talk about data, we're going to talk about open source tools. We learned a little bit about that this morning in the keynote, talking about 3JS. But then also there's a whole host of commercial platforms out there. There's not enough time to talk about all of them, but it is important to become familiar with those. And then also we're seeing a lot of presence these days in commercial gaming engines. So let's go through a few of those, but first let's talk about data. So important. There's a number of different formats that data can exist in. Originally, really, it's Autodesk that has dominated the AEC industry with their applications and, of course, their data, and they aren't exactly open about how they share that. However, one format is used for interoperability. It's quite old. It's DXF. There is an SDK that allows you to get data in and out of DXF files, and that has traditionally been the way Autodesk has allowed you to share data within their applications and also outside. And it's actually a pretty good format for visual fidelity with multiple descriptions of materials and textures, but it's just not modern. Some of the more modern formats that are open, IFC is huge. One of the real benefits of IFC is it has a lot of additional data outside of just the objects. It has metadata and data organization. So that is a real benefit. It's being standardized, particularly it's by governance in Europe. You need to be able to support projects that include this 3D file format. One of the drawbacks of this is it's text-based. So it's pretty heavy, it's hard to parse. It's not exactly nice and neat, so you need to be able to standardize on it and make sure that you're reading and writing them appropriately. Not everyone writes them well. As well, you have to do some modeling in order to actually visualize the data within IFC files. We'll talk about that in a little bit. When it comes to even more modern file formats, GLTF is a huge standard. It's an open standard. It supports a high level of visual fidelity, really driven by the gaming industry with multiple layers of textures and an approach to rendering called PBR or physically based rendering. So in addition to your different color channels and transparency, you have other descriptions like metalness and roughness and your specular channel. So it's a very complex file format, but is able to represent data in this really meaningful way and give a high level of visual fidelity. The new kid on the block is an open format called USD. And we're just starting to hear a lot of conversation around this, and different companies are really pushing the use of USD for a number of different reasons. It came from originally Pixar, but now we're seeing it really in the industrial metaverse and industrial applications. It has a rich graphical definition, but it's an open standard that is moving forward with more than just a tessellated format that sits underneath it, but they're talking about boundary representation and intelligent objects. And it's continuing to evolve. So it's really exciting to see what's happening in USD. You have to be able to support all of those different file formats because data exists in that, and depending on what type of ecosystem you're trying to build an application to support, you need to be able to support that data. Additionally, there's some closed standards. So Autodesk, again, they have a number of different file formats that don't have open descriptions. DWG, tremendous amount of legacy data coming in from DWG, so that's the native file format for AutoCAD. Navisworks is another Autodesk acquired application that is able to aggregate a lot of data and visualize large models. That file format is closed as well, and then Revit has really been a struggle. How do we get data in and out of Revit, which is now really the most popular AEC application where people are authoring data. Bentley as well, they have their DGN file format. So there's just a huge matrix of data that we need to be able to support. But once we get that data in, we want to be able to work with it. We'll talk about how to do that. But before we go there, what are some of our open source tools that allow us to visualize and interact with this data? One of the biggest ones is Three.js. So a huge community around this web viewing technology. It has a massive community and ecosystem. You are able to get data in using GLTF, so you have to convert to that. But then there's other readers that allow you to get data into an application based on Three.js. If you are needing DXF data, so that's that Autodesk format, it's somewhat legacy, but there is a loader that allows you to bring data in there, as well as IFC using ifc.js. So it is a pretty versatile platform. In fact, Autodesk decided to use this as the basis for their most modern up-and-coming viewer part of what was Autodesk Forge, now the Autodesk Platform Services. So they've decided to actually leverage this technology commercially, which is really exciting. Three.js is a web technology, but still a lot of work is being done on desktops. We want to move everyone to the cloud. So this technology and other web-based technologies, one of the best ways of deploying it on the desktop is to use a pretty readily available technology called Electron. So you're able to wrap a web viewer, web technology, and deploy on desktop. A really great example of that many of us use is Slack. That's Electron-based technology. They're able to bring web to the desktop. So an alternate technology and viewing platform that is specific to AEC, specific to performance, large-scale visualization, and precision, Creox ZeoKit is another SDK that allows you to visualize 3D data on the web. You can wrap it in Electron to deploy to the desktop. It is an open source viewer, highly performant. I love these guys. They're great. They have a slightly larger set of tools for bringing data in. Their documentation's great, and it's AEC specific. So when it comes to building on top of Three.js, there are certain things you're going to have to build yourself that's specific to your workflows. This toolkit comes with a number of already pre-built tools that allow you to interact with AEC data. They have great visual fidelity, supporting those physically based rendering channels, as well as being able to support point clouds, a number of different file formats specific to point clouds. Now remember, I told you about IFC data, where you have to do a little bit of modeling around it. Well, what's great about IFC data is it represents walls as objects, and it represents a door as an object within that wall that's actually a cutout. It's called a Boolean operation. So they actually don't tessellate out many times the wall with the borders around a door or a border around a window. Instead, they say, here's a solid object, and here's a cutout of that solid object. We're going to leave it up to the developer to actually interpret what do you want to do with that. That's great because it's true to the original data, but it's actually computationally can be quite hard to actually create those cutouts. And so you need a modeling kernel to do so. One great example is Open Cascade modeling kernel. This is what they're known for, though they have a viewer, though they have some file readers. The benefit of using Open Cascade is you can then create those cutouts or other Booleans that are important for AEC. So if I want to do sweeps for piping, or I want to do extrusions to actually create building elements, if I draw a profile and I want to extrude it up, this is what you would use a modeling kernel for. This is what you would use Open Cascade for. In fact, this is the basis for IFC OpenShell that is a JS, which is a tool for importing IFC data. And so Open Cascade is a great technology. You can extend it. We're going to talk a little bit about the TechSoft tools. Using Hoops Exchange, you're able to get data in using Hoops Exchange from a number of other file formats. So those are some of the big open source tools that are out there. There's also a lot of commercial tools. This is the world that I'm in. We use a variety of open and closed tools. What's nice about some of the commercial tools is they're hardened. Commercially, you have a commercial support system that's very responsive. It's able to mitigate risk. It can really help you accelerate your product development and get to market faster. One example is kind of like in between, called the Open Design Alliance, really the premier provider of AEC data. So files like Revit, that's closed from Autodesk, they've reverse engineered that, and they're providing access to Revit data for the majority of the people in the industry, including TechSoft, Dassault Systems, and a number of other ones. They support DGN, IFC, Navisworks. This is really their bread and butter. They have a number of other tools focused on mechanical CAD, focused on viewing as well, but the Open Design Alliance is pretty great when it comes to providing rich AEC data. It is an alliance. You do have to pay a membership to it. You do kind of just sit within that alliance. So sometimes responsiveness can be a little bit slow because you're part of a much larger group of people that are asking many of the same questions or different questions. Another big provider of technology in this space is TechSoft 3Ds. That's the company I work for. We are the largest supplier of 3D engineering SDKs in the industry. We have a number of tools for data. We call that Hoops Exchange. We actually provide access. We're a member of the ODA because they do a good job. We provide access to DWG and Revit through the ODA, but we've decided to reverse engineer DGN, IFC, and Navisworks ourselves. And then we also have an integration with some of the Siemens tools. We have graphics for desktop using Hoops Visualize, for web using Hoops Communicator, a number of simulation tools, and then we also resell a data toolkit called Real DWG from Autodesk. We're going to talk about that in a second. AutoCAD OEM, we'll talk about that too, and Siemens Parasolid. But really providing visualization and data to a number of these players as well. Happy to talk to you about them. But how about Autodesk and AutoCAD from Autodesk? There's more data out there, more CAD data out there than any other type. Real DWG or DWG is the most prominent CAD data out there. And though the ODA, Open Design Alliance, provide access to DWG files, it is reverse engineered. It's not 100% correct. They have to reverse engineer it every 3 years when Autodesk comes out with a new format. Real DWG is an SDK for reading DWG files natively. It's what Autodesk uses themselves. It's my preferred method for reading DWG files, because it ensures that you get 100% accuracy in all the data within that. AutoCAD OEM is an amazing set of tools that allow you to get to market incredibly fast if you want to build on top of AutoCAD. Essentially, as a developer, you get a copy of AutoCAD with a number of wizards. You're able to reskin it, add your own plugins, remove functionality, create an installer, and then distribute it as your own type of software. So it's an incredibly fast way to get to market using a market-hardened piece of software. The drawback is it's desktop-based, and you have to work with AutoCAD or Autodesk One of the challenges of working with them is if you get really good, they see you as competitive, and one of two things can happen. There'll be a cease and desist letter, or they'll acquire you. So if you're really successful, you take your chances there. Autodesk Platform Services, APS, also known as originally Autodesk Forge. It's a set of tools that sit in the cloud. The graphics are based on Three.js. However, they have their whole suite of data access tools. They use a company called CAD-CAM-E that provides a lot of their data access, but they have modeling tools and simulation tools and a whole slew of tools that sit on the web. Incredibly powerful. It's kind of their next generation of AutoCAD OEM. However, one of the drawbacks of that is you're beholden to their ecosystem, so they don't really allow you to bring your data and your hosting elsewhere. You have to host on their cloud using their infrastructure, which is a real challenge in a world that's ever more divided when it comes to data sovereignty and owning your data and bringing it wherever you want. Talk about walled gardens. Spatial was acquired by Dassault Systems some time ago. This is another big player in the space. They have data access called Interop. It was originally MCAD focused, and guess what? In order to support AEC, they align with the Open Design Alliance as well. What they're really known for, not only just mechanical CAD data access, but really modeling as well. They have the ASYS modeling kernel. That actually is the basis for AutoCAD modeling. They forked that code years ago, but there's a lot of overlap still between the AutoCAD modeler and ASYS. They also focus on aerospace because they are owned by Dassault Systems. They have the CATIA CAD system really focused on aerospace. So they also have the CGM modeling kernel as well. It seems like there's some competition between the two of them for resources. Their graphics actually come from TechSoft 3D, so if you want web viewing, they use Hoops Communicator from TechSoft. If you want desktop viewing, they use Hoops Visualize from Desktop. Speaking of like commercial modelers, Siemens is really the commercial modeler to use. So even though Dassault Systems and Spatial, they have the ASYS and CGM modelers, Siemens really seems to be the market leader commercially when it comes to having a modeling kernel. In fact, Bentley uses it under the hood for their modeling. ZWCAD, a big competitor of AutoCAD, they use it for their modeling as well. And this is, if you need to go above and beyond just some simple modeling functions, really the recommended way of doing that. I like them particularly because their support department is amazingly fast, responsive, and well-informed. Just absolutely love working with Siemens. Wow, gaming, we're going to be talking a little bit about I think Unreal later. Just amazing graphics, and they really are starting to push into our space of AEC applications. It does require some effort to get data in there. A lot of that is being done using Hoops Exchange. So Unreal, Unity 3D, as well as the Omniverse, they all use Hoops Exchange from TechSoft 3D to bring in data. But just amazing systems to bring data in. So all of this is incredibly beneficial. I don't have time for my demo, which is fine. But basically, we're going to load a file, convert it using an API. Then we're also going to isolate a part and do a measurement on it, and do so programmatically or with the interface. At the end of the day, we want to be able to write some code. We're happy to do that within some JavaScript. And then a conclusion, so where's everything going? Well, AEC data access really is dominated by the Open Design Alliance, so I do recommend checking them out. They have some great technology. There really is a shattered landscape. So when you talk about data and modeling and simulation and graphics, pretty shattered landscape. Each of them have their benefits and their drawbacks with some great open source, some great hardened vendors as well, commercial vendors providing software. There's really a growing presence of these video game vendors. And one of the things I really have a call to action is around a need for open data APIs for better interoperability. Each of these file formats really have benefits and drawbacks, but there's still a file format, there's data loss, there's versioning issues, and so really opening up data as part of a set of APIs that sit within a data lake is really the future of where we're going. I'm happy to talk to you more about what we do or the industry in general. There's my email. If you want a copy of the slides, I'd be more than happy to share that with you. And we have 25 seconds for a question.